Hello, hi everyone. Welcome to the class. So this is our Sir. Today we are going to discuss about electric current, CBSE Grade-10 physics. Let's discuss about electric current. Electric current. Electric current, electric current, electric current. The rate of flow of charge is called electric current. SI unit of current is ampere. SI unit of charge is coulomb. Electric current. Electric current. Okay, so CBSE grade 10 physics. CBSE grade 10 physics. CBSE grade 10 physics. Electric current. Okay, so what is electric current? The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. Okay, so we can say I equal to Q by T. So that is the rate of flow of charge. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Right? So here you can see SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. Right? Okay. So that is electric current. The rate of flow of charge is called electric current. Okay, let's start. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is called electric current. Electric current. Okay. So here in the conductor, so this is the conductor. So I am considering, so I am assuming a conductor. So now here charges are moving. Charges are moving. Will you able to say if only one charge is moving, will you able to current is flowing? If only one electron is flowing? If only two electrons flows, will you able to say current is flowing? If only three electrons flows, will you say current is flowing? No, we can't say, right? We can't say. So when we can say current is flowing? When we can say current is flowing? When number of charges are moving in the conductor. If number of charges are moving in the conductor, then we can say current is flowing. Number of charges, yes or no? Number of charges are moving in the conductor, then only we can say current is flowing. Current is flowing, right? So I equal to Q by T. So Q equal to, Q is the quantization of charge. So here number of charges, positive charges are there, negative charges are there. Positive charges are there, negative charges are there. There are many charges are moving in the conductor. Many charges are moving in the conductor. Okay. So that's why it is called quantization of charge. Number of charges are moving in the conductor. That is the reason we are saying current is flowing. Current is flowing. So I equal to Q by T. Q equal to NE. Q equal to NE. So plus or minus NE. That too plus or minus NE. Understand? Plus or minus NE. N is the quantization of charge. N is the number of charges are moving in the conductor. N is the number of charges are moving in the conductor. On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, 1.6 into 10 power minus 19 coulomb. Okay. So on one electron, this much charge is present. So on one electron, 1.6 into 10 power minus 19 coulomb present. In 1 coulomb, how many electrons are present? So that is 1. In 1 coulomb, so 1 by 1.6 into 10 power minus 19. So then we can say 1 by 1.6 into 10 power 19. 10 power 19. If you do it 1 by 1.6, you'll get a 0.625. 0.625 into 10 power 19. So 0.625 into 10 power 19. So that is, you can see here. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. Understood? So once again, observe carefully here. So 1 ampere, so SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. Okay, so quantization of charge. Coming to quantization of charge. Quantization of charge is nothing but number of charges are moving in the conductor. So we can't say only 1 electron, 2 electrons, 3 electrons, 4 electrons, like that it flows. We can't say current is flowing. There are many charges are moving in the conductor. Then only we can say current is flowing. I equal to Q by T. Okay, so Q is the quantization of charge. So that is the number of charges are moving in the conductor. Q is the quantization of charge. Q is the quantization of charge. So Q equal to plus or minus NE. Sir, why you are taking plus or minus NE? Plus is for positive charges, that is nothing but protons. Negative charges represent electrons. Negative charges represent electrons. So positive charges and negative charges both are moving in the conductor. Right? So you can see Q is plus or minus NE. On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, how much charge is present on one electron? 1.6 into 10 power minus 19 coulomb. In 1 coulomb, so 6.25 into 10 power 18 electrons are present. In 1 coulomb, 6.25 into 10 power 18 electrons are present. 10 power 18 electrons are present. So I hope it is very clear. So that's enough. Now So we'll discuss about electrical elements. Electrical elements. Electrical elements. So we'll discuss about electrical elements. Those are electrical elements. So first one is cell. This is a cell, positive terminal, negative terminal. Second one is battery, positive terminal, negative terminal, like this, battery. Next one, so third one is switch. This is switch. And fourth one is, so here is open switch and closed switch. Two different points are there, open switch and closed switch. So this is the open cell, battery, and here open switch, okay, and here it is a closed switch, and coming to the fifth one, resistor. Resistor is a device which is used to oppose electric current in the circuit. A resistor, this is a resistor, and coming to the sixth one, rheostat, and seventh one, cell, battery, open switch, closed switch, resistor, rheostat. Next one, ammeter, this is ammeter, positive terminal, negative terminal. Eighth one, so voltmeter, so positive terminal, negative terminal. Next one, so wire joining. 10th one, wire crossing, and 11th one is bulb. So this is the bulb. Okay, so these are electrical elements. Once again you can observe here. So cell, battery, open switch, closed switch, resistor. So here we need to talk about resistor. Resistor is a device which is used to oppose electric current in the circuit. So resistor, okay, and second one is resistance, and third one is ohm, and fourth one is symbol. Okay, so observe here one thing. Resistor is a device which is used to oppose electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. So symbol for resistance is this one. Symbol for resistance. One, check the electrical elements. Check those electrical elements. Okay, so these are resistor, rheostat. Next one, ammeter. Okay, done. Yes, of course, definitely. Resistance depends on temperature. Resistance depends on temperature. Correct. So here you can see resistor. Resistor is a device which is used to oppose the electric current. Resistance is the phenomenon of opposing the electric current. And the SI unit of resistance is ohm. Symbol for is resistance. Okay. So actually here, so he asked how. So I'm taking this conductor. Very good question. Conductor. So electrons are moving, right? So electrons are moving. Suppose electrons are moving in the conductor, like so. Charge is there. Positive charges are there. So when it is moving, when temperature increases, what happens? So normally there is a drift speed. There is a drift speed. So normally electrons are moving in a closed enclosure. In a conductor, directly proportional. Yes. So in a conductor, electrons are moving. Yes or no? In a conductor, electrons are moving. That in a closed path. Okay. So we have so much. So we'll go here and there when college. So at the end of the college, so once it is released, so we'll go in different directions. But here there is no path like that. There is no path like that, right? So electrons moves in a closed path. Then what happens? One electron will hit another electron, that electron will hit another electron, like that. So keep on bombardment, keep on collision takes place. Then automatically, so average speed will decreases. Okay, so that is a drift speed we can say. Thank you so much. Okay, so like that, when electrons are moving in a closed conductor, so it will hit one to each other. Then automatically what happens? Then automatically what happens? So speed decreases. So if temperature increases, velocity of the electrons increases, collision will take place. Then automatically, so more resistance will, so electrons will collide there only. It won't go move. It won't go forward. Okay, no? So electrons will not move forward. So there only bombardment, there only collision will take place, there only hitting will take place. Then that's why, so resistance depends on temperature. So more resistance will be there. So temperature increases, automatically resistance also increases. Right? So that is temperature depends, resistance depends on temperature. Understood? Yes. Now, like that, so that is about resistance. And SI unit of resistance is ohm. SI unit, symbol for resistance is that one. I hope it is very clear. Now, rheostat. Rheostat is a device. Rheostat is a device which is used to regulate the current. Rheostat is a device. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. Regulate the current without changing the voltage source. Okay, device is not changed, we can able to regulate the current. That is called rheostat. Coming to ammeter. So ammeter you can say. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current in the circuit. Okay, so ammeter will be connected in series combination. Voltmeter is a device which is used to measure the potential difference. Voltmeter will be connected in parallel combination. Ammeter is a device which is used to measure the current. Ammeter will be connected in series combination. Voltmeter is connected in parallel combination. It will measure the potential difference across the ends of the given metallic conductor. Okay, so wire joining, wire crossing, bulb. Now, so I'll discuss Electric circuit. So now we will discuss about electric circuit. So ammeter is used to measure the electric current. Suppose if you connect ammeter in parallel combination, so ammeter has fixed reading to measure. Okay. So if you connect in parallel combination, so in parallel combination, so different appliances operate at different voltage. Okay, so then automatically some meter gets slightly heated because more current will pass than it required limit, than it is required measurement. So actually it measures 5 ampere. So certain time, sometimes so more current will passes through that one, because in parallel combination different appliances must be connected to operate at different voltage. So that's why different currents required. So in parallel combination I1, I2, I3 like that already we discussed. So now again we are going to discuss, no problem. So that's why ammeter cannot connect in parallel combination. Voltmeter is not, we cannot, voltmeter is cannot, it's not possible to connect voltmeter in series combination. Sir, why? If you connect voltmeter in series combination, if you connect voltmeter in series combination, it won't show the reading. Why? What is the reason? Because what is the purpose of the voltmeter? What is the purpose of the voltmeter? Voltmeter must measure the potential difference. So in series combination, same current is flowing. So where is the difference? Where is the potential difference? So same current only is flowing, right? So that's the reason voltmeter cannot connect in series combination. Ammeter is not connected in parallel combination, right? Yes. So now electric circuit. Electric circuit. Electric circuit. Electric circuit. Electric circuit. Electric circuit. A closed and continuous path of a closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. Okay, so a closed and continuous path of an electric current. So I'm taking here this the bulb, this the bulb. So that is connected, ammeter is here, and so here I'm taking battery. So battery current is passing like this. So positive terminal, negative terminal. So bulb is glowing. Bulb is glowing. Okay. So current is passing through the circuit. A closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current is known as an electric circuit. First one is conventional current. Conventional current. Conventional current. Second one is electric current. So conventional current and electric current. Electric current, you can see. Sir, what do you mean by conventional current? What do you mean by conventional current and what do you mean by electric current? Conventional current. The flow of positive charges is known as conventional current. Positive charges are moving from high potential to low potential. Conventional current. So positive charges are moving from high potential to low potential, whereas electric current is moving from low potential to high potential. Low potential to high potential. So these are the positive charges. Positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. Conventional current and electric current. Okay. So in the electric bulb, we will use as a tungsten as a filament. So here you can see, until this temperature it can withstand. Until that temperature it can withstand. Okay, so that's why we are using. Okay, so I hope it is very clear. Now you can observe. So conventional current, the flow of positive charges. So positive charges are moving from positive terminal, negative terminal. Electrons are moving from negative terminal to positive terminal. Flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Electrons will move from electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Positive charges are moving from high potential to low potential. High potential to low potential. That is a conventional current and electric current. Conventional current and electric current, right? Yes. Now, resistance and resistivity. We'll discuss about resistance and resistivity. Let's start resistance and resistivity. Resistance and resistivity. 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 So here you can see resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to A. R equal to rho into L by A. R equal to rho into L by A. Resistance depends on resistance depends on temperature, and resistance depends on nature of the material. Nature of the material. Nature of the material. Okay. So and coming to the resistivity, rho equal to Ra by L. Okay. So rho equal to Ra by L. SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter. So rho equal to ohm meter. Rho equal to ohm meter. I hope it is very clear. I hope it is very clear, right? Yes. Understood? So SI unit of resistivity. So this is for 2 marks question. So 2 marks. 2 marks. And especially derivation they will ask. So derivation they will ask. So right from starting, R is directly proportional to L, R is inversely proportional to area, R is directly proportional by R equal to rho into L by A. And here resistance depends on temperature, resistance depends on nature of the material. And here so rho equal to Ra by L, rho equal to SI unit of resistance is ohm meter. Okay. Yes. So now you can observe one thing. So resistivity depends on temperature, and resistivity depends on nature of the material. Nature of the material. Nature of the material. So nature of the material. Okay, so I hope it is very clear. Resistance and resistivity. Resistance and resistivity. Now we will discuss about, so this is about resistance and resistivity. Now we will discuss about, what we will discuss. Resistors are connected in series combination. Resistors are connected in series combination. Check once. Resistors are connected in series combination. Resistors are connected in series combination. Let's start. Okay, so now you can see here. Resistors are connected in series combination. Resistors are connected in series combination. Okay, so I'm connecting resistors are in series. Just check once. So 1, 2, 3. So ammeter. So battery. So here you can see switch. So here you can observe. So closed switch, current is passing. So positive terminal, negative terminal, R1, R2 and R3. So across R1, V1, across R2, V2, across R3, V3. So I'm connecting potential difference. So voltmeters across R1, V1, across R2, V2, across R2, V2 I am connecting here. Across R3, V3 I am connecting here. Okay, so you can observe positive, negative, positive, negative, positive, negative. So here throughout the circuit current is same. Understood? But potential difference is different. Throughout the circuit current is same, but potential difference is different. So Is equal to I1 plus I2 plus Is I1 equal to I2 equal to I3. So potential difference is different, but current is same, right? So current I am taking Is equal to I1 equal to I2 equal to I3 equal to I. That is Vs equal to V1 plus V2 plus V3. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So from Ohm's law, V equal to IR. Then we can take IRS equal to IR1 plus IR2 plus IR3. So I am taking I common. You can take I common and cancel it. So IRS equal to I am taking R1 plus R2 plus R3. So I get cancel. RS equal to R1 plus R2 plus R3. So this is about resistors are connected in series combination. Coming to resistors are connected in parallel combination. 1 by F equal to 1 by V plus 1 by U, 1 by R equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So resistors are connected in parallel combination. So heating effect of electric current. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is about electric current. So if you like the content, if you like my explanation, if you like the channel, please do like, share and subscribe to Student Brand. This is your Sivasa. So signing off. Thank you so much. We'll see you in the next class.